Yo, what's going on, guys? Welcome back. Today I'm doing a video for you called ORM injection. This was actually a video that was requested today actually in the Discord. So if you guys have not checked out the Discord, that's how fast you can actually request videos. If I'm recording a video that day and you request it, I might just pick it. So this video was requested today in the Discord. I'm going to go ahead and do it because it's a very easy box. It's labeled as a medium. I will say it's medium because if you don't understand SQL injection, you're not going to understand this. So that's why it should be a medium. I agree with the finding. One person said to me that the way they do the mediums, highs, lows, or whatever is based on how new it is, which is incorrect. I trust me, that's incorrect. I'm not sure where that thought process came from. Maybe they lower it later as it becomes more common, and that's what they're saying. I didn't really understand that, but maybe someone in the comments can let me know what that means. But anyway, so let's go ahead and hop into it. If you guys haven't checked out the Discord, check it out. The Patreon also has videos every week, and they're not Tryhackme all the time, so actually hardly ever. So keep that in mind if you guys are interested in that content. Now, one of the things with ORM, if you know SQL injection, this will be very simple to you. If you don't know SQL injection, I really recommend you go back and check out some of my SQL injection videos or check out the SQL injection Tryhackme video or boxes, because if you don't know SQL injection, this is just not going to make sense to you. Simple as that. So let's go ahead and get into it. What they're talking about here is basically ORM, object relational mapping. This has been around for a long time, but people use it now basically to try and prevent SQL injection, right, is one of the main things. The reality is this can still have SQL injection in it. It's called ORM injection, but it's still just SQL injection. It's the exact same thing. It's just using a different medium, basically. So we're going to go ahead and talk about it. We're going to go through it, and then we're going to do some actual injection. So let's go ahead and hop into it. There's no point in reading that to you. So understanding ORM. So what is ORM? So this ORM is a programming technique that facilitates data conversion. What that means is, here's your database. Here's your object, right? Here's your code. What's going to happen is it's going to basically translate your code over here, and it will basically create the SQL statements for you. This is great because that means, number one, you don't need to know SQL technically, right? Number two, you don't have to use such advanced SQL queries. That's a big thing. The other thing is you don't have to expose your SQL injection statements directly, meaning when I try to use this website and I say, hey, log in using this username and password, I don't have to make that code run a SQL statement against my database. I can have a medium in between that's going to kind of filter that, and it's going to change the way I write code on the client side or the web application side, right? So it's really nice because these are things that you'll see. You'll recognize some of the names as we go through some of the frameworks and stuff, but basically what it's going to allow you to do is create more complex programs where you don't have to integrate SQL so much. You can just integrate whatever code you're using, and it will make the SQL statements on the back end for you, which is really nice, right? Because like it said here, ORM is particularly beneficial when complex data interactions, meaning there's a lot of complex interactions, and you don't have to directly say SQL statements, right? You're allowed to translate it, and it will still work. That's the really benefit here, is the fact that you can use different data types and it will translate them properly, right? You can use PHP and then it'll turn it into SQL, or you can use whatever and it'll turn into SQL, right? That's the whole point of ORM. You don't have to directly integrate SQL statements into your PHP code. So again, it serves as a bridge between the object-oriented programming and the relational programming, right? So that way you can still program the way you want, but it will translate properly. So here's some of the big purposes. Reduce boilerplate code, right? Reduce the need for repetitive code by automatically generating SQL queries. I kind of disagree with that. Actually, I won't say this. I will disagree with, I agree that that's the purpose. I disagree that this does this. And the reason I disagree is because As you get or programmers that use ORM, you run into the same problem. They use ORM out of the box. They use already found ORM conversions and things like that, and they just basically become boilerplate. Maybe slightly more secure, maybe, but they end up doing the same thing. So this boilerplate code, in my opinion, comes out of laziness, not out of necessity. So I don't think this necessarily does it, but I'm sure there's some developers that would argue me on that, and it's not a hill I'll die on by any means. So increasing productivity. So this is big because developers can now focus on the logic without worrying about database interactions, meaning they can focus on their program and not, I don't care about the database because the database will interact properly because of ORM. I don't have to worry about it. That's really nice. That helps developers a lot, right? Especially developers that historically haven't had that, right? So now ensuring consistency. So ORM frameworks consistently handle database operations, meaning this is what they do. This is their design. They're not reliant on the programmer to not make the mistake, right? ORM will do all of it for you, which is really, really nice. Maintainability. You can make changes to the database schema, blah, blah, without changing your whole code. That's really nice, right? If I make a whole change to the database, I don't have to reprogram my whole code because the ORM allows that interaction still. It's still going to work, and I don't have to reprogram my whole application around the database. Several ORM frameworks are widely used in the development community, blah, blah, blah. So here you go. You got Doctrine for PHP. You got Hibernate for Java, and you'll see there's a bunch of them. SQL Alchemy for Python. You've got Entity Framework for C#, Active Record for Ruby on Rails. I think this is the one they talk about here. Yeah. So these are just different programming languages use different frameworks. That's all they're saying. If you want one specifically, you can look it up. Like I'm not saying it's not good to know, but I wouldn't memorize these by any means because unless you're going to use them all the time, it's not going to help you to memorize them because you can look this up in 10 seconds. Now, what is the default ORM for Ruby on Rails? Right here. Active Record is the default ORM for Ruby on Rails. Pretty easy, right? Which of the following is not a feature of ORM? It's right here. Increases the attack surface due to direct interface with the database. We just talked about how ORM is kind of a medium or a mediator for the database and the application. So therefore, you don't have the direct interface, and it doesn't increase the attack surface. So now, how does ORM work? Well, it maps objects in code and database tables, right? So here's a good example. This is Laravel's Eloquent ORM. Here's one of the actual codes, the snippets, right? So they're using the app models, and the class they made is user. Well, all they did was say, hey, the table is going to be users, and what you can fill in is name, email, and password. Super easy, right? If you've ever used SQL, you know that's going to be a column for every database, right? Not every database, I shouldn't say all the users' database, because you're going to need their name, or it's going to be a row, one of the two, right? You're going to need their name, email, or password. That's it. In this context, that's all you need here. So this will create a user in your database. Well, this is JSON. This is much nicer than simply having a SQL code, because SQL code can have a lot of mistakes. It can get really complex. This can do that for you because now you told it, give me a name, email, and a password. It will make the SQL statement for you. I don't need to do anything else, right? So here you go, creating a new record. Here's what it looks like, creating a new user. Now the code, look at how much simpler this code is, right, to implement into your application. New user, in this case, they used admin. There's their email. And then the password, they used bcrypt to actually encrypt it, but there's your password. And then save. That's it. Now, if you don't know SQL injection and you're and you're a programmer, this is a hell of a lot easier to use than SQL. I'll tell you right now. It's not so much that it's easier to use either. It's that it's easier to integrate with your applications. Look how easy this is. These are just variables, right? These are basically just variables, and you're saying user, and then here's the name, then here's the email, here's the password. They're basically just variables. That's way easier to implement into your code. Now, then the other nice thing is, if I go to change something on the database, how easy is it? I don't have to change anything in this code, really. right? Because if I still need users, maybe the database table they're stored in changes, whatever. This doesn't change, right? Maybe instead of their name, email, and password, I ask for their name, email, and address and password. Well, that's easy. Add a new line. I don't have to add a whole new SQL statement or anything like that. Just add a new line. It'll make it for me. That's really nice, right? So now they're just telling you that bcrypt works. Okay. Reading records from the database involves, okay, so this is reading the records, right? I was scrolling down, it was scrolling up. Okay, find a user by ID. Well, look at that. User, find one. I want to find user ID 1. That is way easier than the select statement that you're going to need, right? Now here, find all users. That's way easier than remembering select star asterisk from users table, right? Because like I just said, what if that table changes? What if the table instead of users becomes usernames or something, right? Now I have to know the actual tables or go in and change my code. In this case, I don't have to because all of this can be handled by the ORM. Now you can see, find where the admins are. Admins equals user, where email is admin@example.com. And then get. Try not to sneeze. Excuse me. Okay, and you can see, here's what that actual statement would look like, that SQL statement. Select everything from users where email equals admin@example.com. Well, that, excuse me, that is a lot easier here to put into your application from a coding perspective. So now, comparing SQL injection and ORM injection. Well, look at how easy these are comparatively. This is SQL injection. Select everything from users. Goodness, I can't stop seeing. Select everything from users where username equals admin or 1 equals 1. That's, everyone's probably seen that 1 equals 1 as the SQL injection, right? Well, look at ORM injection. This is all handled by on the back end, right? This is that code that we already saw. And then they just say admin or 1 equals 1. My God, these allergies are killing me. So you can see this part of it, the payload part, looks exactly the same. There's no difference, right? It's how do we implement it that might be different. So you can see it always evaluates to true, which is all we need it to do. So if you know SQL injection, this is going to make a lot of sense. It's going to be very easy for you, right? So here they're telling you how to configure the environment. We don't need to configure the environment here. This is just for your reference. So you can see they're giving you the connection, the host, the port, the database name, password, all that stuff. And it's stored in an environment variable. This is pretty standard, but this is just telling you how to set up the Laravel right here and then setting up the migrations. So this is version control for your database. So basically, hey, I have a new migration, I have a new version. There you go. It allows you to easily modify and share the database schema. Perfect. Create a migration where you can use the artisan command. So here you go, PHP artisan make migration, create users table. So, and then here, create users. So they created a users table. That's a version, right? They updated something. That's all they're saying. And each framework will have a different command so just whatever framework you're working with, you'll have to look that up. That's why I'm not going to dive deep into this, because they don't require you to stand one up, and it doesn't help you here because maybe I show you the PHP one, but then you're going to do Python or something, right? So it doesn't really help. But you can see here's the PHP code for it, right? And you can see password, email, name, and then they required it to be unique. Perfect. Easy enough. Okay. Now, there's a couple things we want to take away here. In the above code, up, you can see the function up here defines the structures of the user table. So that actually defines this, right? It's saying this function will define, it needs an ID, a name, email, password, right? And then they add timestamps in here as well. So that defines the actual structure, and then down drops the user if the migration is rolled back. So what that means, public function down, if you roll it back, it will get rid of it, right? It'll take it down. So if you roll it back, hey, cool, we'll drop that user, whatever user since the change. Now, you can see after defining the migration, run the command to apply the migration and create the users table. So it'll create that users table. There you go. And then this command will execute the up method and the migration file and the blah, 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 blah. Okay, so that will automatically create the whatever table you're wanting in your database. Well, this is way easier to work with than if you've ever seen the SQL statements to actually create a users table. Now, the SQL statements to create a users table is much smaller than this. There's a lot less, right? But from a coding perspective, from a programming perspective, this makes a whole heck of a lot more sense. And this is a lot easier to not make a mistake and be repeatable, right? Because, yeah, I can make a SQL statement that's going to create a table and all that stuff, right? But if I have to have the application directly interact with the SQL database, what do we have? SQL injection, right? Or SQL injection opportunity. Now, what is the method used in our Laravel code to define the structure? We just talked about it. It's up. That's the method right here. Up. All right. Now, what is the file that stores the database credentials? Environment. Perfect. Now, let's identify some ORM injection. So there's a couple of ways to test this, right? One, you can manually review the code and look for things such as where raw. Why where raw? Because that means it's going to take whatever you put in the input field in a raw format, and it's going to do XYZ with it. So that means if I can break out of that by using my raw code, there you go. So I can manually look for these vulnerabilities. I can use automatic scanners, right, that are used to detect ORM code, right? Or input validation testing, perform manual testing by injecting payloads into the application and see what happens, right? And then error-based testing, this has been around forever with SQL as well. This is purposely putting something in there, incorrect, malformed, whatever, and seeing if you get an error. If you get an error, you get details about what it is, and that's pretty much going to give you whatever you need. So the first thing with ORM injection is you may not know the framework right off the bat, right? So if I don't know the framework, right, I don't know what actual vulnerable methods I need to run, right? If I don't know that you're using Django, I don't know that I'm looking for raw. If I don't know that you're using Ruby on Rails, I don't know I'm looking for this, right? So you need to know what framework you're on so you know what is happening, what variables am I looking for? So right off the bat, exploring the target application, one of the big ones right here, technique to identifying the framework. Look at this. It says Laravel session. That's the name of the cookie. Well, that pretty much narrows it down, doesn't it? That's going to be Laravel as the framework. Now, maybe some smart developer changed it so that that's what you think. Maybe, but probably not, right? Keep in mind, not everybody, but 90% of people in IT are lazy. So if this is the default, probably put there on accident because they're lazy. They didn't want to change it, right? Now, reviewing the source code. Look at that. It says Laravel Framework version 5.0 or 5.x, right? Right off the bat. Got one. Don't need to do much else, right? Analyzing the headers. They can sometimes have the information. URL structure. Sometimes the structure itself can give you some information, right? Login and error pages. So when you log in, when you have an error, a lot of times you see things down at the bottom. It might say created by, and it's whatever framework they're using or something like that. Or when you go to log in, you fail, it says something, right? Those all are things that you can use to your advantage. And that should be part of your normal web app pen testing checklists and stuff like that anyway. But you can see here we're going to provide the 1 comma, right? So we'll say 1 comma, and we'll search. And you can see it gives us the error, right? And all it's showing us here is the error. Syntax error or access violation. You have an error in your SQL syntax. That may not seem like much to you guys, right? But that tells me right off the bat, hey, something big's going on because it ran my SQL code. I just put a 1 and a comma, and guess what? Or apostrophe, whatever. And guess what? It ran that as SQL. That's why I have a SQL error, because it ran that directly as SQL. That means, hey, I can run SQL, right? So right off the bat, very vulnerable because I can run it as SQL. So if you don't know SQL injection, you're going to struggle with that part too, right? Even identifying it, you may go, okay, I identified something. I see an error. I don't really understand it. Well, we just talked about the 1 equals 1, right? Well, if I put that in there, guess what? It's running that as SQL. So right off the bat, I'm going to get an error, and I'm going to be able to use that error, right? So it says, what is the path to document root? Well, if we look at the environment and details here, the document root, here is the actual variable. Here's the C users admin administrator downloads ORM injection public file. And there you go. That's the variable. Now, what is the ORM library for the Spring framework? Well, they tell you already, but if you go back up, it says right here, Spring framework, the ORM library is Hibernate. Now, once you've reviewed the cookies, to identify what is the cookie name that is responsible for maintaining the session in the attached application. Well, there's only 2 cookies. It's probably not the XSRF token. It's probably the Laravel session, right? There you go. So right off the bat, we've identified what it is, and we've identified what framework. So that's really nice. And we've identified that it's vulnerable. So that's really easy for us, right? Now, here we're going to talk about weak implementation versus secure implementation, right? So what we're going to do is, you can see we already did that. So let's look at how this code works by the developer, and then we'll actually look at the 2 different fields, right? So this is the vulnerable one. This is email vulnerable. So it says, hey, request input email, okay? And then the admins are where raw email right here. You notice it says where raw. We just talked about that. That means they're going to take whatever we put in the email, and they're going to directly, anything we put in there, it's not going to sanitize, it's not going to do anything. It's going to run that automatically, right? And remember, this is going to create a SQL injection based on our raw data. That's really nice, right? And then if the users work, perfect. If not, not found, right? Well, that's pretty nice, because look, here's what it does. Retrieve the input. It takes the email parameter, right? Then it constructs a raw SQL query using where raw, which directly incorporates the email value into the SQL statement. Meaning, if I change that email value to something like this, 1 or 1 equals 1, if I use that or statement, it directly takes that and actually runs a SQL statement, right? It's just like SQL injection. It's taking it and it's putting it into a SQL statement for me. So I'm doing the same thing, but it's actually using ORM instead of the SQL, right? In this case. So that's easy enough, because if anyone knows SQL injections, this is the oldest SQL injection in the book. Well, we can take this and we can run it, and I was looking for a link to the site. I can go back up here. You can take this, go back down here, and we can run this. Didn't mean to put emoji. We can run this, right? Search, and look at that. We get all the admins right here. John Doe, Jane Doe, both admins. Pretty nice. So now we do a detailed exploitation. Okay, the attacker visits the input field on the website and enters a crafted, such as what we just did. Then the search blind vulnerable function, which is this function right here, right? This is what it runs. It runs email equals 1 or 1 equals 1, which is true, right? And then you can see it's going to ask if the users is equal to users, which is true, which is what we just validated. You know, we made it say true, right? So now let's look at how do we make that more secure. Well, for one, you'll see it says where here, but it doesn't say raw, right? That's a big one. Why? Because the where method constructs a parameterized query, okay, behind the scenes, meaning it's not going to run your code. It's going to change it into a data field, meaning this is going to be a string, for example, and this is an example, but this we will take your email 1 equals 1, whatever, and we will make that a string, not an executable code. We'll parameterize it. So that makes it not executable. Really nice, right? So that is the secure way to do it. And if you look, when we put this in here and search under the secure, we get user not found, and then we get a flag, right? So it does not work when it's securely implemented because it doesn't allow you to break out of that, right? Because it's going to take what you put and it's going to parameterize it and say, nope, you're not running as code. You're not going to run this in your SQL statement. You can use the data, but you cannot run it in your SQL statement. Now, many people will say, okay, that's cool, but that means right off the bat, that's all you have to do and you have secure ORM. Everything's secure, right? Well, a couple things. One, what I just say about IT people, especially people that are high stress environments like programmers, developers, things like that, they're lazy. And sometimes it's not laziness, it's lack of time, right? And if they don't have time to do it, guess what? Right? Sorry. Right? If you're getting breathed down your neck all day long to get your work done, right? And you need this done now, I'm going to do the fastest thing I can, right? And guess what? Developers are not security folks, meaning it's not their job necessarily to know how to do this code securely. Now, I say that necessarily because they should know secure coding techniques, right? But if they don't, it's not necessarily their fault, right? There should be a security team that's validating. There should be checks in place before something goes live. There should be a lot of things in place before that code goes into production. Now, what email is associated with the name Jane Doe? Well, we saw that at jane@thm.com. We saw that when we ran the admin one. What's the name of the vulnerable eloquent method that's using this task? And it was where raw. We just talked about that. And then what's the flag value after submitting the payload? Well, that was that flag, THM secured 01. All right. Now, while secure coding practices are... Now, how a developer might inadvertently implement a vulnerable version. We just talked about that, right? It can occur due to developers using outdated or misconfigured ORM libraries that contain inherent security flaws. One thing I really want to harp on here is this is one of the biggest, in my opinion, the biggest risks with things like ChatGPT, OpenAI, Copilot, all that stuff. Because developers specifically are using these constantly to build their applications because it's fast. I understand. I'm not hating on it. I don't have an issue with it. But understand, as time progresses, development skill set is going down because they're using things like OpenAI to build the foundation and then they're building on top of it, right? That's okay. But understand this is the risk, because guess what? If you're a developer, and I just talked about high stress environments and things, and you can build that application in 10 seconds using ChatGPT for your job, right? And then you start building on it and stuff, and it works. Are you going back and checking, is that actually configured securely? Is that configured properly? Because I will promise you, ChatGPT notoriously doesn't do that. So understand there's a big risk in this. And this is where I see a huge risk in about 5 years, because all these applications and things, yes, they're being built by AI. And I understand that that's inherently a risk, but that's the big risk that I see happening, because misconfigurations and outdated ORM libraries, they still work. So if you're a developer and you're trying to get your job done and you make it work, is anybody going to check on that for you? Is anybody going to validate it? I hope so, but just know that's a big risk. So one example is this query builder package, which had a significant vulnerability in it, right? So this vulnerability allowed SQL injection through unsanitized query parameters. So you can see up here, it was query users sort name. Well, when you click it, whenever it would do that, it would go ahead and query the users and sort by name for you, Alice, Smith, and Bob. But one thing you see here is you're only getting 2 results. Well, you can see the Laravel equivalent translation of the query is this. This is what it would do. Select everything from users, order by ASCII limit 2. Meaning, okay, we see a vulnerability here because you're showing 2 of my users. But from an attacking perspective, I say, well, you're showing me users. How do I just stop the limit, right? I don't need to do a whole SQL injection here. Let me just stop the limit. Let me stop right here and say, select everything from users, order by name. I don't want this limit here. Well, that's where ORM comes into play, right? Because when you run that, you can see if we try injecting just the name parameter with the asterisk there, or asterisk, I'm sorry, the apostrophe there, because we want to say name and cut it right there. That's what I want. That's the end of it, right? It returns an error and says, hey, unknown column, name, and then it's got 2 commas or 2 apostrophes there. So that means it took it, but it just doesn't work out, right? So what do we have to do? Well, the nice thing is we can use JSON here because that's what it's written in. And we can say, hey, use this operator, the JSON operator with the %27 payload. Now, you may say, what is %27? Well, if you go to CyberChef, %27, it's your apostrophe. So this time, instead of us using the actual apostrophe and it reading it as a string, we put it into the URL and we say, hey, look at this. Query users, sort name, and then we say, we took that limit, right? Well, look at this. The limit's there, but look what's right before it, %27. So we're actually cutting that limit off. We're doing this, right? We're saying, hey, yeah, it's there, but stop the query right here. So we click this, and look at that. We get all the users. So you can see you can actually manipulate it using similar SQL syntax, but you're using ORM syntax in this place, right? And then you get all of them. So what is the total number of rows in the users table? Well, 1, 2, 3, 4, 5. 5. What's the password for John? His password is Tryhackme 101. All right. So that's ORM injection. It's basically SQL injection, but you have to change the syntax and pay attention to the different mediums that it's using, right? And then now, there we go. Okay, so important practices. Input validation. This should be standard now, but it's not because people are lazy and stressed, right? So always validate user inputs on both client and server side, meaning there should never be an opportunity for inputs to be running code, right? That's what ORM, one of the purposes, is for, but it has to be properly implemented, right? Parameterized queries. This, again, we just talked about. Prepared statements to interact with the database. This approach ensures that user inputs are treated as data, not code. They should be data, not code. So if you put 1 = 1, I go, no user exists because that's the name I'm looking for versus that's the code I'm running. Okay, ORM usage. Utilize ORM built-in tools to interact with the database, meaning don't interact with the database directly, right? It abstracts SQL queries and helps prevent SQL injection by handling user inputs securely if configured securely, right? Keep that in mind. Don't assume ORM just automatically makes you secure. Now, escaping and sanitization. We just showed the escape character, which was the apostrophe, and then we just used %27 instead of the apostrophe. Escape user inputs to remove any special characters for injection, right? You should be removing escape characters. Now, allow list. Implement an allow list approach for input validation. Only allow specific expected values and reject everything else. Very similar to like whitelisting applications and things. Reject anything that you don't whitelist. That's what they're saying. Now, application of popular frameworks. We're not going to get crazy with this, but use prepared statements with parameterized queries to prevent SQL injection. Here's the PHP doctrine. Here's SQL Alchemy, Python, right? They're just showing you here. Query API use parameterized queries. So they're just showing you best practices for each one. Java, .NET. Is it good to practice to write raw SQL queries in ORM? No, you should not, right? Now, which side should you input validation be carried out? Both. You need to be input validation on both the server and the client. Otherwise, there's going to be an opportunity for risk there. All right, guys, that's it. That is ORM in a nutshell. This is a very easy box if you fully understand SQL injection, but if you don't, this will be foreign to you. So make sure you go back and check out SQL injection. If you guys like this, if you guys like the ORM or any of the other stuff, check out the Discord in the description and let me know what you guys want to see. Also, make sure you guys comment on what you want to see next because I'm doing the SOC paths as well, but there's a ton of video or a ton of boxes in there, keep in mind, so it takes time. I have a limited amount of time, so if there's something you'd rather see outside of that, let me know in the meantime, and I will try to cover it for you guys. Thanks.